Hello, everyone. Thanks so much for coming here this afternoon, for making it all the way up to the room formerly known as the Leader Circle room, which I actually find super fitting for this session because I have one ask of the audience. Have a thought about what it would take for you to be a leader for sustainability in your own organization. My name's Chris Talbott. I work with customers across the globe, helping them understand ways that Google Cloud can make them and their IT infrastructure and their applications and their data analytics pipelines more sustainable. I actually meet with more and more organizations every week who are asking questions about what goals they can set with regards to sustainability for their IT infrastructure, for the products that they design and develop and market to the world, and for just generally the goals that they set. But I'm more excited about what my friend Jake will come up and talk about, how they're using Google Cloud Platform to make solar accessible for all. So at Google, in addition to our mission of making the world's information universally accessible and useful, we have a similar mission for sustainability, that we want to build sustainability into everything that we do and all of the products that we deliver for our customers to use. And what does that sustainability built in really mean? It means from hardware to data centers, we're going to prioritize sustainability in our value chain. That could mean incorporating as much as 75% post-consumer recycled plastics in our hardware, to actually purchasing all of the ugly produce, the fruits and vegetables that otherwise wouldn't be purchased from restaurants, and using those in our cafes and serving to our employees and all of their guests. But I'm going to focus on two areas that I think are most important for you as a potential user of Google Cloud Platform or G Suite. And that's data centers and energy. So we're going to focus on those two areas, and I'm going to try and take a second to highlight the type of innovations that we've done in those two areas that you could only get from Google Cloud. So data centers are the heart of everything that we do as a company, serving all of you as users of Google Cloud Platform, as well as the 8 other products from Google that have over 1 billion users each. And it's a really critical part of the equation when it comes to how sustainable we are as a company and how sustainable you are as a user of Google Cloud. With 2% of the world's electricity already being consumed by data centers and the increasing digital transformation that we are all experiencing, this is only going to grow. But it's actually an area where innovation can have an incredible amount of impact. Compared to 5 years ago, we deliver 7 times the amount of compute per watt of electricity that we use. Google is known as one of the best in the industry and getting the most compute out of the electricity that we use. And the way that you measure this is through something called PUE, or Power Usage Effectiveness. And that's essentially for every watt of energy that goes to compute, how much overhead electricity do you have to use for cooling and the facilities and the security and keeping the lights on in the data center. And at Google, we have a PUE across our data center fleet of 1.11. So we only need 11% extra overhead in order to support the compute workload that we have in our data centers. And that's what we mean when we say 50% less energy used from our data centers. If you look at the industry average, the PUE would be around 1.6, 1.7 in that range. And you, as a user of Google Cloud, you get the benefit of this efficiency. And there are a couple really innovative ways in which we are able to deliver efficient data centers. So one of those ways is through free cooling. So if you're familiar with data center operations, one of the biggest users of electricity within a data center is cooling down all of the servers that are running super, super hot. So we strategically place our data centers in places where we might be able to get free cooling. To cool a data center, you either use air or water. We use water in most cases. And in this particular case, in the south, we actually collect rainwater next to the data centers and use that in order to chill down our servers. And I guess we built really, really nice and comfy and convenient rainwater collection pools because now we have wildlife. This is an alligator from our North Carolina data center living in one of the free cooling rainwater collection pools. In Finland, we put a data center in an old paper mill plant, and they actually pump seawater in from the ocean and use that to cool the servers in our Finland or Hamina data center. The other way that we're able to make our cooling systems really efficient is by optimizing the system that controls the cooling within the data center. So when it comes to controlling data centers, it's super, super complicated, and they're kind of unique beasts. There's millions and millions of components that are relatively fickle to changes in the environment, like weather or a particular component in some area of the system perhaps breaking or being changed in an unoptimized fashion. So manually controlling millions and millions of inputs and knobs and dials is pretty inefficient. And pre-built industrial control systems, they usually optimize one part of the system, but at the scale of a data center, they don't really work. So when you're facing a problem of trying to predict a positive or an optimal outcome from millions and millions of inputs, neural networks are really good at solving that challenge. So we actually use neural networks, as you've seen this GIF sort of run through the steps, to control the data center cooling system across our fleet. And it's a pretty typical sort of AI use case. So you see from the start here in September 27, when we were testing this out, that the benefit was relatively minimal. But as the system got more and more data and learned from optimal scenarios by taking those inputs from the temperature throughout the data center and optimizing that for a future temperature, we were able to achieve a reduction in 30% in the electricity that goes to cooling our operations. This is one component of getting our PUE down to that 1.11 level. And getting the most out of the electricity that we use is super important, but equally as important is procuring energy in a responsible way. So before we talk about energy, it's probably worth doing a little primer on how electricity use corresponds to procuring renewable energy. So as this GIF kind of runs in the background, I'll explain the basics. So the majority of the electricity that we use, you probably know, is from the grid available to us, wherever we're plugging something in, or in the case of data centers, wherever that data center is located throughout the globe. And it's drawing energy from that electricity grid. And of course, the electricity being provided to that grid comes from various sources, everything from coal-fired plants to nuclear energy to solar and wind, what we would consider renewable sources and carbon-free sources of energy. And when you actually procure renewable energy and invest in renewable energy to be produced, like in the case of this, a wind farm, as that energy is produced, something called renewable energy certificates are associated with that renewable energy. So when we use the energy on the back end, while we're using all the electricity that's available on the grid, which of course is sourced from the various different types of sources, both carbon-free and carbon-based, we can account for the renewable energy that we had previously invested in and match that to the actual electricity use that we use. And we do quite a bit of renewable energy procurement. So this past September, we announced the largest corporate purchase of renewable energy in history, 1.6 gigawatts. This was a package of agreements, 18 different agreements, both wind and solar agreements, some of them in Finland, Belgium, Sweden, and Denmark, so relatively local to here. And with these new deals, it brought our total capacity of our portfolio of renewable energy to about the capacity of 1 million solar rooftops. So an incredible amount of renewable energy that we are procuring because, quite frankly, our business requires us to use a lot of energy. And this investment that we recently made in September was just the latest step in our overall goal of ensuring that we match every watt of electricity we consume around the world for our operations, everything from keeping the lights on in our offices to running a Google Compute Engine instance in one of the regions in London, that we make sure that that electricity we used is matched with a watt of renewable energy that we have purchased. So what does that mean for you as a user of Google Cloud Services? Well, it means that there are 0 net carbon emissions when you use a Google Cloud service. So if you're using G Suite, if you're using Calendar, if you're using BigQuery, if you're using App Engine, Google Compute Engine, all of those services are matched with the renewable energy that I just mentioned, and it makes your usage of Google Cloud net carbon neutral. So when you're moving IT infrastructure or building a new app that was previously on on-premises infrastructure or perhaps a co-location provider, you can make a huge difference in your own carbon footprint by moving that to Google Cloud. And this is probably the single most important part for you as a user of Google Cloud if you want to kind of push your own organization forward into potentially a more sustainable position. Carbon neutrality is sort of the most obvious lens to think about renewable energy and the sustainability decisions for you as an IT practitioner. But there's some other ways to look at this. When we procure renewable energy, it actually provides us with long-term power contracts that have a much more reliable and predictable price over a very long horizon. And you can see kind of the precipitous decline in both wind and solar prices for this renewable energy. So this is actually setting us up with a foundation to be able to have a reliable energy source, which is a significant input to our business into the future. And while renewable energy may be reliable on a long-term horizon, it's actually super not predictable in a short-term horizon. So in order to make sure that we can provide the lowest cost services, which electricity is a major input in the cost side of the equation, we want to make sure that we get the best prices for the renewable energy that we have in our portfolio. So the same AI algorithm, same AI type technology that we use in our data centers to control the cooling, we actually use to predict how our wind farms are going to produce wind power, and then it helps us price the wind power much more accurately, because on the markets, an energy source that you can predictably price, it can often be more valuable. I mention these things because, when I talk to customers, sustainability often becomes this conversation, well, of course I would love to do that, but, first I need to consider cost and reliability. And, through these lenses, cost and reliability are actually part of the sustainability equation. Efficiency has always been sort of adjacent to reliability for us at Google. Our fault-tolerant design is based on a kind of simple principle. Design these planet-scale systems that could tolerate the loss of a particular component and be totally fine. And our hardware design is simple and efficient as well. We remove everything superfluous from the machines and essentially write incredible software to use those machines at scale. So efficient and reliable. And like I mentioned, that procuring a more predictable, more reliable, and better priced power source for the future helps us deliver lower cost services to you as a Google Cloud Platform user. So I mention these things because you can actually look at sustainability and being more environmentally positive in terms of your impact from a couple different lenses. But we shouldn't lose sight of the fact that simply on a carbon emissions basis and environmental impact of migrations, you can have significant impact by moving to Google Cloud. So National Geographic, probably most of you are familiar with the brand, an incredible portfolio of amazing images. This is an image from an a photographer named Joel Sartori. He takes animal portraits, kind of like you would take human portraits. And all of these images are stored in National Geographic's image library. They recently moved that library to Google Cloud, and as part of that process, we analyzed the previous infrastructure that ran in it actually ran in kind of like an IT closet in Washington, D.C., and calculated the environmental impact that they made by moving that to a carbon neutral platform. And it's not insignificant. So they reduced their emissions by 17,000 kilograms of CO2 per year, which is the equivalent of burning almost 20,000 pounds of coal. Or one way to think of that is how much forest it would take to capture that much emissions, kind of similar to what they did by moving to a carbon neutral platform. And it would take 20 acres of forest to capture that amount of emissions. So if you're thinking about that application, or perhaps those old servers that might be running somewhere, think about what the environmental impact of those are, and with a potential positive impact that you could make by migrating those to a carbon neutral platform. And I mentioned, I had one asked, and that was to consider what it would take to become a leader. When I talk to customers throughout the globe, a lot of folks don't realize that their company may have already made a commitment to sustainability, either in reducing their scope 1 or 2 carbon emissions, or perhaps just generally reducing environmental impact, or reducing overall electricity. So, my ask is for you to ask your company about its sustainability goals and whether IT can participate in that. Also, check out the difference in carbon intensity of powering yourself versus moving to Google Cloud. For most organizations, the ability to procure renewable energy isn't readily available to them. These markets aren't totally open. It usually takes a significant amount of investment. We've invested billions of dollars. So actually procuring your own renewable energy might not be an option, and you might be sort of subject to whatever is available to you on the grid where you operate. So take a look and consider what it would mean to move to a carbon neutral platform. And we can help you do that. Your Google Cloud account team has options for doing consultancy arrangements where we could calculate the kind of exact impact similar to that National Geographic use case about moving a workload to Google Cloud. And then finally, tell your own story, which I think is the most interesting part. Ultimately, we're going to provide platforms that are sustainable, that are carbon neutral, because we want to empower everyone, from nonprofits to individual users, to use this technology and hopefully, make the world a more sustainable place. And I'm going to run a video of a local company who has done that. A local organization that's done that.
The main challenges facing wildlife today is habitat loss, climate change, and threats from the illegal wildlife trade. Zenithel's mission is to create a world where wildlife thrives. We work in over 50 countries around the world where we empower and inform people to help stop wild animals going extinct. We have been working with Google to look at how we can use Cloud AutoML to really make a difference.
We use camera traps to monitor the state of the planet. They are tiny little digital cameras hooked up to a little motion sensor, basically. So when an animal walks past, they snap a little photo, which you can then retrieve at a later time. As well as telling you about how abundant different species are, they can also offer behavioral insights as well.
One camera trap study generates hundreds of thousands of images. So over 6 months, you might get 500,000 images that you need to sort through and analyze.
You've got to go through every single image. You've got to label them, the time, the date, what it contained, which camera it was. At the moment, it takes months.
If we can speed up the analysis from 6 months to just days, that's revolutionary in our conservation efforts. Google Cloud AutoML allows conservationists who are non-coders use machine learning to create image recognition models to identify species in camera trap images.
These are images that I have labeled, and they're going to teach the AutoML algorithm what different species look like.
If you can just AutoML it, you could go, show me the images that are empty, show me the images that have the animal that I'm interested in. You can actually use your scientific research and conservation time to do conservation rather than doing data analysis.
We might use the data to actually influence policy change or conservation action. AI is going to play a really big part in collecting all the data together from wildlife conservation sites around the world. And if we do that in real time, we can use AutoML to really monitor the pulse of wildlife across the planet.
It's one of my favorite stories. I was actually walking through Regent's Park where the ZSL Zoo is. It's a beautiful place if you haven't been able to check it out. But using a sustainable platform and then developing tools on top of that, in the case of ZSL, using AutoML to recognize images and essentially free their researchers to do more policy work is such an amazing story. And the final point I kind of want to make is that overall there's a movement for preference and positivity around sustainability. We've done some research internally about the powerful associations that folks have with sustainability. 75% of adults are concerned about the environment. Thousands of organizations have signed on to the commitments to the Paris Climate Accords. Multiple thousands companies have set their own emissions targets. A few hundred companies have actually committed to 100% renewable energy. So there's this amazing momentum around sustainability. And I think we're noticing amongst our customers that their values as an organization really aligns with sustainability and running a sustainable platform and potentially sustainable apps that they deliver to their own consumers. So essentially, it makes business sense to prioritize sustainability in your decision tree. We'd love for you to join us to consider sustainability in the decisions you make in your app development, in your design, and in the choice of your infrastructure, and to really be a leader, to take this platform, the data, the partnership, and build for the future. And I'm excited to welcome up a customer who is doing just that. So Jake, why don't you come up here? Thank you very much.
Hi, everyone. So I'm Jake Wachman, and I run software for SunPower. And if you're not familiar with us, SunPower makes the highest efficiency solar cells and panels in the world, and we sell them all around the world. So I joined SunPower about 4 years ago to make our software as awesome as our hardware. But before I get into all the cool things we've done on Google Cloud, using Google Cloud and the apps we've built on top of Google Cloud at record speed, I want to talk a little bit about hardware. So this is the Solar Stratos plane that will soar at about 80,000 feet above the Earth, and will do so only using solar cells, specifically SunPower solar cells. The reason being that our cells are 22.7% efficient, and you can squeeze the most power out of a limited area of a wing. So when people look to low temperature, hard conditions, they often look to SunPower to power their innovations. One of those companies is actually an Alphabet spin-out, Loon. And if you're not familiar with Loon, they power their balloons using SunPower cells that then provide internet service all around the world at 60,000 feet. So those little panels down there are actually our solar panels helping to provide internet access via an Alphabet company, Loon, all around the world. And those are the same panels that go on a roof. They go on roofs all around the US, all around Europe, Asia, Australia, and we made about 10 gigawatts of this stuff. So 10 gigawatts of solar panels is roughly equivalent to taking about 40 million metric tons of CO2 out of the atmosphere. We're taking 9 million cars off the road for a year. And we're just getting started. Only about 2 million homes in the US have solar on their roof. We've got 100 million more to go. And that's just in the US. So there's so much more we could do, but I think that solar in the US and other countries has what I'd call two major problems. It has an awareness problem. People don't really realize that solar can save them money. It can reduce the carbon in the atmosphere. And then it also has a workflow problem. So just kind of going solar in the US is particularly difficult. Not exactly as easy as buying other consumer electronics like a Pixel phone or a television. Really hard. My team spends a lot of time thinking about how do we solve both of these problems with software, and how do we make it easier for people to know how much solar can do for them, and then also make it easy for them to go solar as well. So who in the audience remembers televisions? No. I do. I have one, I'm sorry to admit. And buying a television is a relatively easy thing to do. You can measure the wall, and they come in pretty standard sizes. Yeah, it's consumer electronics at its simplest form. You can get a 65-inch TV, you can get a 55-inch TV, all the way down to 49 and 27. We want to make buying solar as simple as that. Measure the wall, figure it out, small, medium, large. Unfortunately, it's nowhere near that simple because no two roofs are the same. They have chimneys, they have pipes, they have different angles, and even when you have a house that looks exactly the same as another house, it's not on the same part of the earth, and there might be different vegetation around it. So you can't really say, this system is going to do X, Y, or Z for you without knowing what it looks like on the roof. And that's where software comes in. So knowing what it looks like on the roof, knowing the actual system design is really core to being able to tell the customer, you're going to save this much money, you're going to do this much from the environment, and here's how much it will cost you. So let me give you a little example of how difficult this is. This is a house in Berkeley, California. Looks relatively straightforward. Maybe you could fit 20 panels on this roof. Our designers have a hard time, eyeballing it. We actually have to get in there and draw it all out because you've got a chimney. There are various skylights. There are all sorts of pipes of different heights and sizes, and all those could cast shade on a module, which you wouldn't want to place a solar panel right next to those. And then if you're going to put panels on the roof, we also need to have walkways for access during emergencies. Not to mention, of course, all that greenery around the house that you don't want to touch, called trees and bushes. And from a 2D view, it's really hard to figure out how tall those are. So we have people who spend hours every day making solar designs for customers manually. It takes about 30 minutes so that we can provide them with a real estimate of what solar can do for them. And it's a really hard problem when you start to consider the three-dimensionality of it. This actual house in Berkeley, California is on a hill, so the hill is a little bit up there, and then the shade cast is a little bit different than if it were just on a flat piece of ground. So if you ask me, how good is my house for solar? How much should I pay? How much can I save? In the past, it's been really difficult because we've had to go and get a 30-minute manual design made, and when you add all the turnaround time on that, it can become hours of waiting, or maybe you find out the next day. Nowhere near as easy as to buy as a television. So we've created something called SunPower Instant Design. And back in April at Google Next San Francisco, we announced this, and we were very excited to announce this, this new technology that takes an address and within seconds, using machine learning, creates a design. We built it with Google's Cloud ML. And I'll show you exactly how we did it, and then I'll actually show you the technology. So SunPower has a lot we bring to the table. We have hundreds of thousands of solar designs we make for prospective customers. We have design knowledge that we then turn into algorithms. We also happen to have a really great sales platform that we can actually use to go to the market with the customer. And when we combine that with Google's cloud platform, which is especially fast and really well designed for this kind of innovation, as well as Google's unprecedented and kind of uncomparable map data and sunroof data, when you mash that all together, you can create some really cool stuff. So here's how it works. We have hundreds of thousands of designs we create every year. Google has raw data. We train machine learning algorithms based upon those designs so that whenever anyone enters an address live at that point, we can detect the edges of the roof, detect the obstructions, all those trees, the pipes, the chimneys, and then our software built on Google Cloud lays out the panels, runs a shade analysis, and creates an energy estimate so that then you get a solar design in under 30 seconds. So I think, yep, here's a video of it. And so we have this test environment where we enter an address. This is that same house in Berkeley, California. It takes a little longer to enter the address than it does to actually design it. You click Create Design, and it's running through all the outlining of the roof. It's doing the chimneys. It's figuring out how tall the trees are, casting all the shadows, putting the panels in the best spots, and then calculating the energy that comes off of those panels. And within about 30 seconds or faster, you get a design. In 3 dimensions, you can zoom in, you can see the obstructions, see where all the panels go, which is pretty cool. And this, thank you. Yeah. So we're pretty excited by this, and we launched this in April, or we announced it in April. And then, we made a bunch of designs. These designs aren't perfect. We could probably fit a few more panels on this roof, but it gives you an idea of just, how different and complex every roof is. You can see a bunch of them here. You'll notice that we actually have some panels on the north side of the roof. That's not where you'd actually want panels at the end of the day, because in most places in the world, except in the southern hemisphere, that isn't going to produce a lot of power. But we want to give the customer the optionality to say, I want panels in certain spots based upon my preferences, whether they're aesthetic, economic, or energy goals. Because some people might want panels on the back of their house if it's most optimal. This is a house in Europe. Some, if they're especially excited about solar, might want them on the front of the house. And if you have a new house that's relatively energy efficient, such as here in California, you only may need a few solar panels. But then, as will become more common when people get EVs all around the world and they have more energy needs and more of their energy coming off of electrical, or more need for energy for their car, they may need a much larger system, such as shown here. So that's the technology, and that was something we discussed in April. What really excites me, though, is how we're bringing it to market and how fast we can bring it to market because of our ability to deploy on Google. So in September, just a few months later, 4 or 5 months later, we launched what we call SunPower Design Studio nationwide in the United States. And this is how homeowners can actually access, live on sunpower.com, this cool technology. And they can go and they can type in their address, put in their electric bill, and then see a design within 30 seconds. So I'll show it to you now. So here we are. I've already entered the address. You select a bill, click View Design, and then that same house in Berkeley, you can use the slider to add more panels to the roof and watch your savings grow. And then, with our existing sales technology, people can go in and actually change individual panels around to achieve their aesthetic or their economic goals. So this is live right now in the US. We've had people are currently making every week thousands of solar designs. And the data shows that they're twice as likely to become solar customers than if they were to just fill out a form. We're getting them more engaged, we're helping them realize their potential, all with software. Now this is pretty cool, but there's just so many more roofs out there. There are all those roofs that aren't attached to houses. And this is a photo I took of Compton, California, a couple years ago over the state. This is the middle of California. And what's funny about this photo to me is all the blank, empty roofs in the middle of California in 2018. All those roofs could be doing something for the building owners and the inhabitants in them. They could be creating power. So we thought, where can we take this next? And so this week here at Google Next UK, just a couple months after we've launched our consumer experience for homeowners, we're very excited to show instant design for commercial buildings. So instant design for commercial buildings is very similar to the residential experience. Get an address, and within 60 seconds, because these are much larger roofs, we can create a design. Here's an empty roof, one of those roofs not using its full potential, retailer in the Bay Area. You can see it's actually looks somewhat simple because it's flat, but there are a number of skylights, HVAC units, and then what's particularly difficult about this roof to understand, and where the machine learning helps a lot, is that pipe running down the middle. You can't put solar there. So a lot of flat roofs actually have pipes running around for various reasons, conduit, et cetera. And so we fed this into our platform. We fed this into our trained machine learning algorithms. And within 60 seconds, we made this. And we can do it repeatably all around the world. And what's really kind of makes exciting for me is that we have totally characterized this roof. We know every single kind of HVAC unit and skylight. and we can see it in 3D. So that's actually a zoom in of the dual tilt helix system that every single solar panel and every single obstruction with height and that pipe mapped out. Able to tell a commercial building owner within seconds how much they can save with solar, what solar can do for them. And for commercial building owners, this is really very different than this current state of affairs because they take days to learn what solar can do for them, weeks, because there's so much iteration. We can iterate much faster. We actually gave this solution to a couple of our internal analysts who often analyze building portfolios, and within hours, they were able to analyze 86 buildings that would otherwise have taken them many days for a particular retailer in the United States. So we've shown the residential software and the residential instant design off for almost a year now. This commercial instant design is relatively new this week, and we often hear about things like, well, why just the US? What about Australia? What about France? Why can't we use this in our own home country? And the answer is, now you can. So we're also excited this week to talk about Instant Design API. We have one major energy company in Europe piloting it today, and we're interested in anyone in the audience or anyone who's watching on YouTube who might be interested in taking this outside of the US and using it for their purposes. Wherever we can get digital surface models, it works. And this innovation was also made possible by Google Cloud. We would never been able to do it as quickly as we could without all the building blocks that we built, as well as the actual API abilities of the cloud. So there it is. We have Instant Design API, SunPower Design Studio, all enabled by Google Cloud. If you want to learn more, go to sunpower.com/instant, and you can sign up for learning more about the API, or go try a US address for SunPower Design Studio and see how it works. So zooming up for a minute, I get really excited about ML. I get really excited about technology. I think that this is one of the cooler uses of machine learning in my mind. This and medicine, in my mind, are some of the higher purposes. And if we can just help just a few thousand more customers to understand solar and understand its potential because of this new technology, we've really done our job. But we can go much further. There's 100 million future solar homeowners in the US. There are millions of commercial buildings with billions of square feet of roof space in the US alone, and much more all around the world. And so we think technologies like this, other things to help solve those workflow problems and that awareness problem, are really going to help impact the world and reduce our carbon, put more solar on roofs. So with that, that's a wrap. Thank you for your time. We also, I think, would love for you to fill out the survey if you have a moment. And I think we have about 10 minutes left if there are any questions. Yeah. Anyone in the audience?
We'll also stick around.
Yeah.
Feel like shy.
Does anyone want to buy a solar power system? Yeah, go ahead. Yes, we will. The API would work. It works in the UK. We just need to work out the best mapping provider. Yep. The question was, any thoughts on solar roof tiles as opposed to panels? There are some famous solar roof tiles out there. SunPower actually was in the solar roof tile business earlier in 2006 or so. I personally like a concentrated area of panels. It's much more understandable, easy to install. There are a lot of number of benefits to it, but all solar is good solar. Yep. Any other questions?
Cool.
Great. Well, one more.
Thank you. Have you done any kind of meta work almost whereby you design the solar panels on top of Google Cloud data centers so that you yourself are running MI to work out how best to use solar on that roof?
I may have done that. Maybe there may be some things in the works on that. Check back soon.
So have you done any work so far on sort of the maintenance of solar panels when they break? Because I assume that there's probably quite a lot that you can do with ML in that space as well.
So the best thing about solar, in my mind, is that it just sits there. It's sand, silicon, glass, and aluminum. So aside from, frankly, golf balls in residential installations, we don't often see them break, which is awesome. Now, one thing that does happen is you might get them covered in some soot or bird poop. Bird poop is actually a big problem. So you may want to wash them. And that's especially true of larger systems. And so I know people are working on kind of like knowing when to wash them based upon ML photos of them. We also, of course, just do the standard, kind of reliability testing and things like that. But it's a pretty like set it up once and forget about it kind of technology.
Yeah, thanks so much.
Yeah, thank you.